Air bubble is trapped in a glass of refractive index 1.5. Radius of sphere is 4 at distance 1 from center, where it will appear when seen through nearest. Suppose this is center O. So 1 from center, you can take right side also, you can take left side also. Which one you want to take? Right or left? Pardon?
Any side.
Right hand side you are taking here, na? So this is suppose object P 1 centimeter from center. Radius is 4 centimeter they have given. If I call this as M, this as N, then which is the nearest end of the bubble? M is nearest, na, to this bubble, correct? And from N is far, because you have to see from near and farthest distance from the bubble. So this is farthest distance of the bubble from M, and this is closer one or nearer. This much logic clear?
Yes.
Now, for first case, nearer end, what is object distance U? Is it 3 centimeter?
Yes.
On the left, na? And inside N, object is inside, so from inside that light will come outside. So N1 is how much? N1 means that glass 1.5, N2 it is going in air 1, and V we have to calculate. Radius of curvature is 4 and center is on the left hand side from this surface which we are observing, left hand side, so minus. What is formula for single spherical surface? N2 minus N1 upon R is N2 upon V minus N1 upon Q. Followed this formula?
Yes.
Now N2 is 1 minus 1.5, R by convention minus 4, N2 1, V we want, N1 1.5, U is minus 3. 1.5 into 2. So minus of 0.5 upon minus 4 is 1 upon V plus 1 upon 2. 0.5 into 8. So this will become 1 upon V equals to 1 upon 8 minus 1 upon 2. Therefore 1 upon V is LCM 8, 1 minus 4. Therefore V equals to 8 upon minus 3, which will be equals to minus 2.7. Okay, so that means left hand side of the nearer end. This much followed?
Yes.
So this is first case. Just write solution. So it is from the eye on left hand side at 2.7 centimeter.
Yes, sir.
Second case. Case 2. If seen from N, that means from far surface, then where it will be seen. Now U, case 2. U is 4 plus 1, 5 on the right hand side.
Yes.
V I don't know. N1 is again 1.5, N2 is air 1, R is 4 centimeter because center is on the right hand side now. So same concept, N2 minus N1 upon R is N2 upon V minus N1 upon U. N2 1 minus 1.5 upon 4 equals to 1 upon V minus 1.5 upon 5. So minus 0.5 upon 4 equals to 1 upon V minus of 0.3. 5 3s are 15.3. So this will be minus 1 upon 8 plus 0.3 equal to 1 upon V. So this will become minus 1 plus 2.4 upon 8 is 1 by V. So V equals to 8 upon 2.4. No, 1 minus 1.4. 1.4. Therefore, V equals to 80 upon 14. 2 into 7, 2 into 40. 7 into 5, 35, remainder 5. 7 into 7, 49. So 5.3 centimeter on right hand side. Okay.
Yes, sir. Thank you.
Now, third one. Any doubt in third? No doubt now, Uns. Third one. Fourth, any doubt? Fourth sum.
No, sir.
Fifth, sixth, any doubt?
Any doubt till 20.
Acha. Now, no doubt till end. Okay, so directly I can start with numerical now. With MCQ. Yes, Veer, for you any doubt?
Sir, the
Ah,
first question,
first
the
question. One
yeah,
minute.
the second part of it,
First question, second part.
yeah, where the virtual object is there. I didn't understand those calculations, like the last final part.
First question, example one you are saying.
Yes, sir.
A parallel beam of light strikes the glass. What will be, where will it get focused on the other side? So in that second part you want, see, light is entering from AP one side, na? From A into glass, correct? Hello?
Yes, sir.
Where is the object? Parallel, so it is at infinity. Ray is parallel to the principal axis, therefore it is at infinity. And diameter is 20, so radius is 10. So for first surface, I get image at 30 centimeter as per that calculation.
Yes, sir.
30 will come outside or it will remain inside. Hello? 30 will come inside or outside?
Outside.
Outside. So this is not actual object for second surface. Object to infinity way, na? So we take that image as virtual object. This time light is going from where to where?
Um, um,
From
for the
where?
for the virtual object, it's outside too.
Ah. So from there it will start, na, reflection.
Yes, sir.
So it will be, our formula is N2 upon V minus 1. N2 means it is going from air to glass, correct?
Right.
That's why it is written 1 by N, because air is 1.
Okay.
Now I think you got idea. N2 upon N1 minus N1 N2 upon V minus N1 upon U. First medium is air, second medium is glass.
So we have to find the location of I.
Of the final one.
Okay.
So now you got it?
Yes, sir.
Okay. Just check any other sums. In board, they will ask very simple sum in the slide section. No other sum?
Sir, question number 20.
20. Okay.
Could you
What?
explain that?
20th. 20 is. A real image is formed. That one?
Yes.
Okay, I'm reading it. Real image is formed by lens at a distance of 20 from the lens. The image shifts towards the combination by 10 centimeter. Shifts towards the combination, okay, by 10 centimeter. When a second lens is brought in contact with the first lens, determine power of second lens. Okay. Now they're telling first object is at 20 centimeter. Now image is at 20 centimeter. Where is object? We don't know. But when two are brought in contact, then the image shifts towards the combination. Towards the combination means it comes closer, na? See,
Yes,
this is suppose single lens. Here is the image. When two are joined, it shifts towards, means comes closer, na? Hello?
yes, sir.
What is same? ये lens का focal length same and object is same, na? So can I write like this? For first case, 1 upon v minus 1 upon u is 1 upon f. So 1 upon v in the first case is 20. Object I don't know, let it be u. This is 1 upon f1, first equation. Then for combination, 1 upon f is 1 upon f1 plus 1 upon f2 for combination. And this combination, 1 upon v minus 1 upon u is 1 upon f1 plus 1 upon f2. So 1 upon v means 10 minus 1 upon u is 1 upon f1 plus 1 upon f2. So 1 upon 10 minus 1 upon u, 1 upon f1 is 1 upon 20 minus 1 upon u plus 1 upon f2. Both sides you can cancel this 1 upon u. So from this we get 1 upon 10 minus 1 upon 20 is 1 upon f2. LCM is 20. 2 minus 1, 1 is 1 upon f2. That means f2 is 20 in centimeter. Now power is 1 upon f2 in meter. So 1 upon 0.2, 10 upon 2 is 5 diopter. Follow? Now follow 20. Then 21, 22. All you got 21, 22.
So you told us to do till 20.
Which one?
So you told us to do till 20 only.
1 minute. There is noise. I can't hear. Which one you said? 20?
So you told us to read the solved examples only till number 20.
Acha, I told only till 20. Okay. So till 20, I think all doubts are clear. No, no. Then next homework for you will be till 29. So that our entire numerical and objective type carrying 1 mark we are completing. So 21 to 29, please practice. Then objective 1 mark already I completed till 14th. We had started with MCQ of different board. Till which we had done in that? First we did, second we did, then I think one we had left in between. I don't recollect which one. And directly I jumped to another sum. Sixth one we have not done. Huh? Just check, sixth one we have done.
Fifth one.
सर वो सर ने बोला कि सर मेरे पास टाइम नहीं है अभी क्योंकि माटोंगा में ज्वाइन किया है कि वो पायनियर के साथ और विशाल सर नहीं है तो पूरा वो ही ले रहा है ठीक है, बोला वैसा तो मैं विले पार्ले में अभी नहीं हूँ, लेकिन 4 जगह हो गया, चेंबूर, अब चेंबूर नहीं, गिरगांव, फिर माटुंगा सेंट्रल वेस्टर्न, फिर गोरेगांव। हाँ गोरेगांव में भी जाते हैं। तो वो एक बोला था, एक सर का मैं नंबर देता हूँ, कोई निखिल जोशी दिया तो नहीं दिया। हाँ विले पार्ले में है क्या? अच्छा अच्छा, नहीं वो मंदिर का भी नाम बोल रहा था, बोला सर मंदिर को तो हम लोग जानते हैं, हम लोग को ऐसा चाहिए जो कोई क्लासेस में उधर का लोकल में नहीं है। तो सर एक ना और अच्छा बंदा है, निकेश करके, निकेश भार्गव, लेकिन वो भी है उधर वेस्ट ईस्ट में। है क्या? अच्छा ठीक है, फिर मैं मेरे इधर से ढूंढता हूँ एक दो जन, कोई वही एरिया में है क्या, क्योंकि एक दशरथ परब है ना, उसके इधर कोई है क्या पूछता हूँ। उसका क्लास है ना, दिवेश क्लासेस दशरथ परब का, मलाड में, तो उसके इधर कोई टीचर है क्या, मैं पूछता हूँ ना। तो मैं आपको आज रात को या तो कल सुबह फिर से बताऊँ। यस यस, नहीं लेकिन क्या है, एक नाम डालने के लिए हो जाएगा ना, वो तो बेनिफिट रहेगा ना, मतलब एज अ पीसीएम पीसीबी पीसीएम भी चारों चल रहा है, वैसा हो जाएगा। हाँ हाँ, नहीं मेरा कैसे सर, वो पहले से है ना वो बैकग्राउंड। अभी आप लोग का बैकग्राउंड क्या जेडबल ही रहने वाला है ना, तो लोगों के वो दिमाग में रहता है, जब उधर बायोन स्टार्ट करेंगे ना तो परफेक्ट हो जाएगा। ठीक है सर, ठीक है, यस यस, देखता हूँ। हाँ हाँ, चलेगा, मतलब एटलीस्ट एक अपने को ब्रोशर के लिए तो कोई मिल जाएगा इससे। ठीक ठीक है, आप तो हाँ हाँ, या तो बोल तो सकते हैं। हाँ, तो आप निखिल को भी एक बार पूछ लो सर। ठीक ठीक है, ठीक। हेलो हेलो,
Yes, sir.
last lecture we did sum number 1 in multiple choice, second, third, fourth, fifth, sixth we have done or not, just check.
We didn't do the fifth one.
Acha, we did fifth and then we went to directly, I think 12th, na?
Yes, sir.
Yes, sir.
Sixth one. Sixth one we have to do, correct. That lens is removed is remaining. Six. See, please practice each sums MCQ two times. Mostly you'll find the questions will be from this only. And CET will be very easy. They won't be even hardly 4 line you will get answer of CET. What is converging beam of ray? Converging beam of ray means they are coming closer like this. These are called converging beam. Is incident on diverging lens means which lens? Concave?
Yes.
Having passed through the lens, one minute. हेलो, हाँ मनीष बोलिए, हाँ लेक्चर है एक्चुअली, 9 बजे करता हूँ, नहीं 8:30 बजे करता हूँ, 8:30 बजे। यस यस, ओके। Converging beam of rays incident on diverging lens. Diverging lens means concave. Having passed through this lens, the rays intersect at a point 15 centimeter from the lens, but on other side. If this lens is removed, the point where rays meet will move 5 centimeter closer to the lens, focal length of the lens is. If we can draw the diagram, then the problem will become very simple. So converging lens are made to incident on concave lens. First I am drawing diagram. Sixth one. Concave lens, principal axis. Converging lens are focused, are incident of this. These are called converging lens. This lens, They are saying it is meeting at a point. At what distance it is meeting? 15 centimeter? Hello? Is it 15 centimeter?
Yes, sir.
And when you remove the lens, then they come closer, na? At by 5 centimeter. This is what the question is. Then it comes closer by 5. Because then there is no bending, no refraction, it comes by 5. Diagram part, I think, clear?
So then the image at 15 centimeters will be the virtual object.
Yeah. No, once the lens is removed, there is no image. Directly this object, this ray is meeting at a point without any refraction.
Yes, sir. So the 5 centimeter, that point is um
See, first we get image here. Then this image gets shifted here, I dash, at this point. Where when you remove the lens, it is not the image. It is just coming and meeting at a point without any lens. So,
on the
so
principal axis.
that means you can use lens maker formula only in first case.
Yes.
So can I say 1 upon f is 1 upon b minus 1 upon u. So focal length I don't know. Object is 15 is my image at first case. Where is object?
The object we take as infinity.
No, that is when it is without object is at far distance coming now. This part we are concentrating on. When you are removing, then this is I dash will behave as object and image is at from lens it is at 10 centimeter. 10 centimeter. So this point will behave as object because there is no lens. After putting focal length, we get image of this as I dash. So image is at 15 with lens and object should be at 10 because when you remove this, it gets shifted by 5. That means when we put the lens, that's the position of object. Hello?
Yes.
1 minute, I will just check what it is. Don't get confused. See, this is without lens, it is coming here. So who is coming? This object all I point is focused here because you are not having any lens. The object, it becomes object. When lens is there, then due to refraction, it gives you image here. So this is actually object distance, and this is image distance. So 1 upon f, 1 upon 15, image is 1 upon 10. So LCM will be 15 and 10. I'm taking 30. So this will be 2 minus 3. So 1 upon f is minus 1 upon 30. F equal to minus 30. Minus indicates it is concave. So actually speaking, this light is coming at one point. Without lens, object will only meet. With lens, we get image. So this is object distance. This was image. Sixth one time. 7th. Sixth one, can I clear?
Yes.
So we haven't done the fifth one. Let's finish the fourth one.
No, fifth we did now. We got answer. Say 6 centimeter.
I haven't written it. I've written the fourth one.
Fifth one you are not remembering. We got answer as minus 6. I'm explaining, but fifth we have done. I think you have not written this now.
So, so even I don't have it.
You don't have fifth sum.
No, sir.
Nobody's having fifth sum. we have not done. Fourth we did. Correct. It was not 6 but 16 we have not. Okay. So fifth time doing. Fifth. Fifth time. This all don't prepare for board exam. Board prepare only that 1 mark wala earlier which we did. A diverging lens with magnitude of focal length 25, so minus 25 centimeter, is placed at distance of 15 from the converging lens of magnitude of focal length. Diverging lens is placed at distance of 15 from converging lens of focal length. This is f1, f2, 20 centimeter. Beam of parallel light falls on diverging lens and final image will come there. Beam of parallel light falls on diverging lens, final image will be there. What is distance between this lens here? 15, no?
Yes, sir.
So we have one concave lens and then convex lens. Distance between them is 15 centimeters. Distance is 15 centimeters between these two lens. Focal length of this is 20 given. This is given 25. If the rays are falling on the parallel beam are falling on this convergent lens, then where will be the final image? This is your question, correct? This will diverge from here. It will diverge from here. And if you produce backwards, wherever it meets, that is the position of image due to first one, correct?
Yes, sir.
Then these rays, they will converge and meet at certain point. This distance we want. How much is object distance? This diagram I think you follow.
Yes, sir.
Final image have to find where it will be formed. So diverging lens is giving the image on the left hand side. At what distance they have not given. Image formed by diverging lens is at focus, correct. So can I say I1 is at 25 centimeter, because when parallel beam is incident on concave lens, then they appear to diverge from a point. That point is called focus. So I1 is at 25 centimeter, correct? Hello. So for convex lens, the object distance will become 15 and this is 25, 40 centimeter on the left minus, and F is 20 centimeter. So can you just predict it is double, na? So that means final image will be at 40 centimeter because object comes at center of curvature, correct? So final image is at 40 centimeter, or you calculate 1 upon V minus 1 upon U equal to 1 upon F, or direct, this is double, so this is nothing but center, so image will be also at center on other side, which is 40 centimeter. Now followed.
Understood.
So now in sequence we have done 1, 2, 3, 4, 5, 6 all. Just write this, draw the diagram, understand, so that we come to 7th one. This section is slightly difficult. Huh? Rest all are easy. This and the spherical mirror. Then light, everything is easy. First, I want to make it perfect in 14th and 16th chapter so that in your college exam you get full mark. Completed 5th?
Yes, sir.
So we have done all numericals. 9 are remaining. Now 7th one. 7th. A lens is formed by pressing mutually the plane pieces of two identical plano-convex lens, each of focal length 40 centimeter. Okay. By pressing it, each of focal length 40 centimeter. It is used to obtain real inverted image of same size of object. Then object should be placed from the lens at what distance? I think this bit easy. Object should be placed at what distance? So first I will find what is resultant focal length of this, because two are joined together, first and second. 1 upon f resultant is 1 upon 40 plus 1 upon 40, which is 2 upon 40, 1 upon 20. So fr is 20 centimeter. We want a real image to be formed of same size. When it is possible, image is of same size when object is at 2f, na?
Yes.
Yeah. So therefore u will be 40 centimeters. Clear?
Yes.
Seventh done.
Yes.
Eight. Will you try it? Just take risk. Appears to be slightly simple. Two thin lenses are in contact. Power of combination. Simple. I think you will get the answer.
So can you do it by yourself?
Which one?
Can you do it by yourself?
Option D. 9. The image of object formed by plano-convex lens. Image of object formed by plano-convex lens is 8 centimeter behind the lens, but it is real and size is 1/3. Wavelength of light inside the lens, that means I can say glass, is 2/3 that in the space. So with this you can get refractive index. So refractive index of that lens with respect to air is lambda a upon lambda g. So lambda a upon 2/3 by lambda a, that means 3/2. So lens has refractive index 3/2. Radius of curved surface of the lens is how much? Radius of curved surface of the lens is how much? Now will you try? Once you get wavelength, I think you get some idea. Because if I got refractive index, then you can use that formula. 1 upon f is refractive index minus 1, 1 upon r1 minus 1 upon r2. Just copy till this, then I'm explaining. Copy this one. Wavelength one apart. I'm clearing it. That telling image is 1/3 of the object. Height of image is 1/3 height of object. So height of image upon height of object is 1/3. That means V upon U in minus is 1/3 because that is our magnification formula. Clear? Hello?
Yes.
Now where is the image form? At distance of 8 meter. No? So object is at 24 centimeter on the left, 24 meter on the left. Now you know you are knowing V, at least I can find focus. So 1 upon F is 1 upon 8 minus of minus 24. So 1 upon F equals to 1 upon 8 plus 1 upon 24. So 1 upon F, LCM 24, 3 plus 1, 4, 6. F equal to 6 meter. Now you know F, you know refractive index, only you have to find R. Since it is plano-convex, so 1 is infinity, one surface. Just complete this, U and F.
Yes.
So after getting F, we can say also 1 upon F is refractive index minus 1, 1 upon R1 minus 1 upon R2. One surface is plane, so infinity. First surface ka curvature you want. 1 upon F we got 6 and this we got 3/2 minus 1. So 1 upon 6 equals to 1/2 into 1 upon R1. 2 into 3, 6. R1 equals to 3 meter. Answer 3. So this is advanced, J advanced 2013. 10th I want you should try.
So isn't R1 infinity?
See, if you take R1 infinity, then R2 will come fine. 3. Anyone you can take. So you can take either this or you can take either this. This is up to you. But one will be infinity, other is our answer.
Right.
Try 9th, 10th one. Ratio of power is 3/2 and equivalent focus is 30. Find individual. I feel that you can do it. Power is reciprocal of focal length. So F2 upon F1 will become 3/2. F2 will become 3/2 F1. If F1 is F, then F2 will be minus 3/2 F because it is concave. Second lens is concave, therefore minus 3/2. Now you will get, you got the idea. 10 and minus 15. Ten and minus 15.
Sure.
How it happen?
So why did you take it as minus 3 by 2?
Because they have given one lens is concave. No? First is convex. So convex, if it is f, in magnitude wise it is 3 by 2f, but negative because it is concave.
Right.
If 10th done, then try 11th. 11th is also, I think, easy. Try 11th, take 2 minutes.
Sir, I didn't get 11.
11th you are not getting. I'm explaining. A person can see clearly clearly object when it lies between 50 and 400 centimeter from his eye. In order to increase maximum distance of distinct vision to infinity. Okay. The type and power of correcting lens the person has to use will be how much? Clearly he can see with naked eye at 40 and 400 centimeter wala object. But we want to increase the distance of distinct vision up to infinity. Then what should be the power of lens? Between which distance he can see? 50 and 400, huh? Bro?
Yes, sir.
That means maximum what he can see is 400. What he sees is image in the lens. So 1 upon V minus 1 upon U is 1 upon F. So if distance of distinct vision is going to infinity, then image should form here only, then only he can see clear. For that he is correcting his eye lens. So this is minus 4 meter. This is infinity. For correction we are putting that focal length. That means lens. So 1 upon 4 is 1 upon F. So focal length is minus 4 meter. That is, it is concave lens to correct it. Power is 1 upon F measured in meter. So it will be minus of 1 upon 4. That is minus 0.25 minus 0.25 payout. 40 and 400 you can see clearly. So ये तो नजदीक वाला है, तो दूर से दूर 400 वाला you can see clearly. But to increase the maximum distance of distinct vision to infinity, that means if object is at infinity, he can see 400 per clear. By putting the lens also it should be at 400. Four meaning is. Will I clear this now? I think 12th we have done.
Yes. Even I think
12th,
14.
12, 13, 14 we did. Come to 15th. This also you can manage. 15th one. 15th. One. An object, we will convert all in centimeter because two things are in centimeter. Object is at 2.4 in front of lens. Forms a sharp image of film 12 centimeter behind the lens. That means object is in front, so minus 240 centimeter. Image is formed of 12 centimeter on other end. So from this we can get focal length of that lens, which will be 1 upon 12 minus of minus 240. So 1 upon f, 240 directly I can take LCM, 20 plus 1. So f equals to 240 upon 21. 3 into 7, 3 into 8. So equals to 80 by 7 centimeter is focal length. What we did then next? A glass plate of 1 centimeter thickness. Glass plate of thickness 1 centimeter and refractive index n of 1.5 is interposed between the lens and film with plane face parallel. At what distance should the object shifted to be in, again, sharp focus on the film where the object must be shifted? What is formula for shift? Hello? Formula of shift, it is thickness into 1 minus 1 upon n, which will be 1 into 1 minus 1 upon 1.5, that is 1 minus 1 upon 1.5, 10 upon 15, 5 into 2, 5 into 3, 1 by 3 centimeter it has been shifted. So our image will be formed at slightly raised. Earlier it was getting formed at 12. Now to this it will shifted upward by 1 by 3. So new position of image will be 36 minus 1, 35 by 3. This will be the new position of image. So we want where should be the object so that we get again same focus. 1 upon v dash minus 1 upon u dash is 1 upon f. So first part here, We got focus this much. Then there is plate of thickness 1 centimeter placed, so there will be shift in the image. That means it appears to be raised. So it appears 35 upon 3. But we want it should, where should be the object now placed to get the same type of focus. So image is when 35 by 3, then where should be that object? Focus it is same. Reciprocal of that will become 7 by 8. 3 goes up. 3 upon 35 minus 1 upon u dash, 7 by 80. So 3 by 35 minus 7 by 80 is 1 upon u dash. Just copy to this. Now just simplify this if you can. Directly cross multiply and then take decimals. 80 into 3, 7 into 35 directly you can do. No need to think of LCM. U dash 3 into 80 is 240 minus 7 5 is 35, 21 and 3 24 upon 35 into 80. So U dash will be 35 into 80 upon minus 5 5 into 7. U dash equal to minus 560 centimeter, which is equals to 5.6. That means in magnitude it is at 5.6 meter to be fixed. At what distance should the object be shifted to be in the sharp focus on the film again? It should be at 5.6. Okay, 15th done. 16th one. Two identical glass rods, one convex, have one convex end of radius of curvature 10. They are placed with curved surfaces at a distance d. Curved surfaces at distance d are shown in the figure, with their axis shown by dashed line. When a point source of light P is placed inside the rod S1 on its axis at distance of 50 from the curved face, the light rays emanating means coming out from it is found to be parallel to the axis inside S2. Then distance S will be how much? Refractive index is given 1.5. Then distance S2 will be how much? So this rod will behave like single spherical surface. This one.
Yes.
So for first rod, I can use single spherical surface wala formula. For single spherical surface, what we know, n2 minus n1 upon r equals to n2 minus n1 upon r equals to n2 upon v minus n1 upon v. This is first rod, S1. So from here the light will go outside. That means this is first medium, this is second medium. So can I say n1 is 1.5 and n2 is 1? and object is 50 centimeter on the left, so minus. Radius of curvature is 10, but center is on the left, therefore minus again 10. Just substitute and tell what is V from here. After solving, tell what is V.
So I got V as minus 50.
How much?
Minus 50 centimeter.
Minus 50. And 2 is 1. Minus 1.5 upon minus 30. And 2, 1, VV1 minus 1.5 upon minus 50. Minus point. Minus minus plus 1.5 upon 50. This is 1 upon 60 minus of 1.5 upon 50 equals to 100. Minus minus 50.
Sir, is it 10 centimeter?
What you are saying?
Sir, is it after 10 centimeter? You
R is 10. Okay, I took that. R is 10. So 1 upon 20. Therefore, 1 upon V equals to 50 minus 30 upon 100. 50 minus 30. 1.5 upon 50, that is 1 upon 20. So 20 upon 100 upon 1000. 1 upon 50. So we are getting plus 50. Hello? Plus 50 we are getting. No? That means here we are getting image. Copy first part. From second rod, this is first medium and this is second medium. Because from here light will emerge and go. Shall I clear this now? Picture? For second surface, second medium is that glass. First medium will be air. Object distance we want. 50 we got B. From the surface it is on the right side. मुझे एक वैल्यूएशन वाला सर्टिफिकेट जैसे रहता है ना जो वीजा के लिए लगता है फॉरेन स्टडीज के लिए वो एक चाहिए था एचयूएफ और ये पर्सन नहीं जैसे हमको वीजा लेना है अगर, हाँ नेटवर्क तो I-20 के लिए एक लगता है और एक वीजा के लगता है हमको। अच्छा एक्चुअली क्या है, वो यश को पढ़ने के लिए जाना है तो वो फंड्स का जो सोर्स ऑफ फंड वो दिखाना है उसको। तो वो बोल रहा था कि जो बैलेंस शीट में अगर जो हमारे म्यूचुअल फंड है वो सब अगर आ जाएगा तो हम सबमिट कर सकते हैं। टोटल अगर वो 80 तक हो तो ज्यादा अच्छा है, मतलब एसेट्स भी चलते हैं उसमें। तो हाँ हाँ वो हो जाएगा उसमें। अच्छा तो मैं फिर आपको मिलूँ 2 तारीख तो या 3 तारीख को, क्योंकि 7-8 तारीख तक उसे चाहिए। तो मंडे आप आओगे ऑफिस में, तो आप आओगे तो मुझे फोन करना, मैं आ जाऊंगा। ठीक है ठीक है ठीक है, क्योंकि लॉकडाउन है। आप कहाँ है, राजस्थान में है? अच्छा अच्छा, थोड़ा केयर लीजिए, बहुत तकलीफ है। ओके केयर लीजिए, ठीक है। Yes, yes. See, while this was first surface, and from here it is 50, correct? I made mistake. From here the image is at 50, correct now? Hello? And this is D. This distance is D, okay?
Yes.
Distance between two surfaces is given this much, and here we are getting 50. So what will be our object distance if we find now for the second surface? Because that if we get, then our problem is solved. This is going 50 here. So total distance from this end we want. This is 50 from here. Can I say 50 minus t?
Yes.
So it is 50 minus t object. And radius is 10 on the right hand side. And they are telling image is ray is becoming parallel. So final image is getting at infinity, correct? Okay. Ray is becoming parallel, they have given after going inside. Yes, is it clear? Hello? 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 Hello, you can hear?
Yes, sir.
The rays emanating from first becomes parallel in the second medium, so image is at infinity na? That's why it is at parallel.
Yes.
So n2 minus n1 upon r is n2 upon v minus n1 upon u. N2 is 1.5 minus 1, r is 10, n2 is 1.5, v is infinity, minus n1 1. This is 50 minus d. So this will become 0. 0.5 upon 10 equals to 0 minus 1 upon 50 minus d. That will become 1 upon 20 equals to 1 upon 50 minus d. So 50 minus d is 20. Therefore, d will become 50 minus 20, 30. Just check 30 is there.
No.
So it's some plus minus mistake I did. They are placed in contact. This is distance d. This object is going from here at 50 centimeter on the right. So from center at 50. हो गया मिस्टेक क्या वो समझते हो ऑब्जेक्ट इधर नहीं रहेगा ना, ऑब्जेक्ट तो इधर है ना, सो दिस इज ये रॉन्ग हो गया मेरा, इट शुड बी d minus 50, ये डिस्टेंस d और इधर से ये 50, so it should be minus of d minus 50 on the left hand side, so it will become minus of d minus 50, minus of d minus 50. Again I am doing second part. N2 is 1, N1 is 1.5, object distance is on left hand side d minus 50, image should become infinity because rays are parallel, r is 10 because center is on right side. So n2 minus n1 upon r is n2 upon v minus n1 upon v. 1 minus 1.5 upon r is 10 equals to n2 1 upon infinity minus of n2 is 1.5 n1 is 1.5 1 upon minus d minus 50. So 0.5 upon 10 is 0 plus 1 upon d minus 50. 1 upon 20 is 1 upon d minus 50. D minus 50 is 20. Therefore, d is 70. 70 centimeter. Right. D is 70. We are done. Done, na? 70. 16th one we did, now 17th. Two identical thin plano-convex lenses, each having refractive in a radius of curvature 20, are placed with their convex surface in contact at the center. Okay. This is same as what we had done last class. The space is filled with refractive index 1.7. Plano-convex refractive index is 1.5. And radius of curvature for both is 20 centimeter. Find the focal length of combination. Will you try this? Focal length of combination? Try, I think you will get. First find 1 upon f1, then 1 upon f2, then f equivalent. 1 upon focal length of combination is 1 upon 40 plus 1 upon 40 minus 7 upon 100. One upon focal length of combination LCM you can take out 2 upon 40 minus 7 upon 100, 1 upon 20. So this is 100. 5 minus 7 minus 2 upon 100 equals to minus 1 upon 50. So f of combination is minus 50. Minus 50 centimeter f of the combination. Completed this? Try sum number 24. And 26 try. It's similar type.
So we try it right now.
Which one?
So we try those sums right now.
Right now try 24th. 24th try. Their parallel surface they are telling is coinciding. Focal length is F4 refractive index P2 and concave focal length is F1, refractive index is N1, radius of curvature R. Find the focal length of combination. Yes, did you get the answer? Is it coming? R upon N2 minus N1?
Yes, sir, now I got it.
Then try 26th. All of you got this sum number 25, 24 properly?
Yes.
Okay. 26 also I think you should get. Two convex lens are placed coaxially. Focal length each. What is the focal length and space between them is filled with glycerin. Focal length of combination and space between them is filled with glycerin. Which has refractive index 1.5, same as that of glass. Then equivalent focal length f2 will be how much? f1 upon f2 we want. First case it is 1 upon f1 is 1 upon f plus 1 upon f, which is 2 by. Second case it is combination of 3. Having same refractive index. So it will become f2 is 1 upon f plus 1 upon f. This will be concave, so minus 1 upon f. This will get cancelled. So 1 upon f2 is 1 upon f, equation 2. So ratio of f1 to f2. 1 upon f2 upon 1 by f1 is 1 by f upon 2 by f. So f1 upon f2 equals to 1 is to 4. 1 is to 2. Just check same answer. 1 is to 2 you are getting.
Yes.
Okay, so that's all for today. Please practice those numerical and whatever sums we did today, that also practice. Friday we'll complete this chapter fully. And then we'll begin with that 14th if something is left out. So 14th, 16th completed, then I will start with